Woohoo! Yes, we're done to the last practice problem. Practice number 4. It's question number 6 or problem number 6 for molar mass. Again, we're going to convert from moles to mass here at the top. You can see what we've got right here, moles to mass. And so we have 1.09 moles of carbon trichloride. Okay, so we're going to figure out how many grams there are in that many moles. Well, the first thing, again, we look at the the number here of that many moles. We got to figure out how many significant figures our answer needs to be in. Well, we have a 0, and that's really what we're looking at. And the rule says if zeros are trapped between whole numbers, then it is significant. So we have 3 significant figures here. So we're just going to go ahead and put a 3 right there. So we know that our answer at the end has to have 3 significant figures. So let's go to carbon tetrachloride. In order to figure out how many moles or how many grams, we need a molar mass. So we want to figure out how much 1 mole of carbon trichloride actually, how much it weighs. So we need the formula. Well, this is a type 3, and here's how we figure out and know that it's a type 3. We look at the first element. The first element is carbon, and we say, is it a metal or a nonmetal? Well, it's above the staircase, so that makes it a nonmetal. So it's a type 3. Another way to look at it is, too, even though we don't have no prefixes here in front of carbon, we do have a prefix right here. And if we have prefixes, that means it's type 3. So what we do is whatever the prefix is, we put that as the subscript after the symbol for that particular compound. If it doesn't have one, that means that there's only one for that. And it also means that we won't have a prefix on the very first element if there's only one of that element. So we're not going to put monocarbon. We're just going to put carbon trichloride. So we're going to put in right here our carbon, and then we're going to put our chloride, which is Cl, and then we have how many of them? Well, this right here, tri means 3. So we're going to go ahead and put a subscript in there of 3, and there is our formula for carbon trichloride. And so why do we need that? Because we got to figure out the molar mass of 1 mole of that. 1 mole is 1 carbon and 3 chlorine. So we're going to go ahead and put down our carbon, and we know that we have 1 of them. Okay, and we're going to multiply that by 12, and that's going to equal 12. Okay, why 12? Well, 12 is the molar mass of carbon. So we do the same thing with our chlorine, but in this case, instead of having 1, we have 3. I'll get rid of that. We have 3 right here. So we're going to go ahead and put a 3, and we're going to multiply that by, I think it's 35. Okay, so we'll double check. And the reason we're going to double check is because sometimes we can't remember what they are. So how do we do that? We go to the periodic table. We go to the periodic table, so we're going to pull up the periodic table. We'll look for chlorine, and whatever the atomic weight of chlorine is, we need to go up, and it's right here, is 35. Okay, so the atomic weight is 35, so 1 chlorine. But sometimes we have to ask ourselves if it's diatomic. We don't have to worry about, in this case, why. And that's, I'm going to go back over here. It would be diatomic, but it's not by itself. It's in this right here. So it's 35 for each of those. So that's going to equal, so now 3 times 35, 105. That's what I think it is. Let's double check. So let's come over here and put 3 times 35 equals 105. So we're going to go ahead and put in here 105, and we're going to add that. Oops. We're going to add that to this number right here. And when we add those two together, we're going to come up with the molar mass. Okay. So our molar mass is going to equal to 12 plus 105. So we're going to go back over here to our calculator. 105 plus 12 equals 117. Let's double check that. 12 plus 105 equals 117. Huh. Okay, so we're going to put 117, and that's what? Grams, grams of this right here, carbon trichloride. So we're going to copy that, put that in there, and that's paste. Now again, what is this for? Because this right here is equal. Okay, it's equal to 1 mole. To 1 mole of CCl3. They're equal to each other. That means they're a conversion factor. So I can put either one on top or either one on bottom, and that will be, they equal each other. Since they equal each other, any number over top of itself is equal to 1. So when I go ahead and do my my dimensional analysis on this, I am really only multiplying by 1. So we're going to start out with our number that we have. We have 1.09 moles of this right here, of carbon trichloride. So we're going to copy that and we're going to paste it right here. Okay, and then as always, we're going to put our times in a line. And we're going to put moles on bottom because we have moles here on top. So I'm just going to come over here and I'm going to put this right there. So we're going to copy this, and then we're just going to scroll over to get to the bottom, and we're going to paste it right there. Okay, and then we're going to take this one right here. I can copy this one since I just got done with it, copy it, and we're going to paste it right there. And then I'm going to just quickly underline it. Okay, once I get to this point right here, I'm going to put equals. And then I can tab this over because I have to have them over top of each other. So when we get done with this, we're going to do the math. But before we do the math, as always, we're going to go ahead and cancel out anything that we can cancel out. So I have moles of carbon trichloride right here, and I have moles of carbon trichloride down here. So we're just going to go ahead and get rid of those. Again, we get rid of those by just striking through them. If you're on paper and pencil, we're just crossing them out basically, because anything over top of itself is equal to 1, and we can get rid of that. So now all we have to do is the math, which is only thing I have left over here is 109. I have 117 grams of carbon trichloride right here, and then 1 mole. So when we go ahead and do the math, we're going to take 1.09, we're going to multiply that by 117, and then we're going to divide by 1, which I don't have to divide by 1, and we're going to end up with 127.53. So we're going to put 127.53, and that's going to be grams. Okay, so we can copy that part right there and paste it right there. Okay, here's our problem though. Our problem is we need it in 3 significant figures. So what do? We're going to go right here. There's a 5 and there's numbers after the 5. So that means because I'm not just ending with 5, there's numbers after the 5, we're going to always round up. So that means we're going to get rid of these, get rid of that number and change that to an 8. And so we know that that's going to be grams. So it's 128 grams of carbon trichloride. That is how much 1.09 moles of carbon trichloride is equal to. Highlight it. There we have our answer. So we're done with our molar mass, moles to mass. There's a lot more worksheets out there that you can use to help you practice. If you need more than that, ask. Other than that, hopefully it helped you out, and hopefully you're ready for the assessment at the end here. As always, go Mohawks. Nelson out.